Hello students, good evening. Right, this is, I thought to share something with you all. I thought I'll start a huge series for you all. Basically, every student, whether it is the grade 11th, 12th, JEE or NEET students, for everybody, the thing which bothers is inorganic chemistry. So there are three important things which you should remember. So inorganic chemistry, if I have to say, only problem is first point, that is you will not have the analysis of the concept. First of all, concept analysis is completely missing in every student, because I see teachers are busy completing syllabus, teachers are busy giving you notes, and you students also, you keep studying for the examination point of view and you forget it. So remember, always first you need to perfectly understand the concept, what actually is there. Done. In point number 2, when I see most of the students do mistakes in applying the concept to the questions. So basically in the JEE exam or NEET exam, or rather CBSE 11th and 12th, you will be given a question that is application based question. So if the concept is clear, you can easily apply in that particular question. Point number 3 is you will be forgetting the different types of trends as well as the reactions in inorganic chemistry. So what I have planned is, I'll be starting an inorganic series from now. So this inorganic series will include starting from the hydrogen of your 11th class, starting from S block of your 11th class, then 13th and 14th group. It will continue till all the group 18 of the P block, transition elements and inner transition elements also. That means the whole of inorganic chemistry will be there in the series. But one condition in this. Here, as I said, I don't want to rush, fast as you finish up the syllabus, you upload some video and see that you're getting views. That is not my concept. As I said, World of Chemistry is that platform where I want each and every student of the class or each and every student to understand that thing. If I start, I just give that, finish off, give you the concept, finally, you will not, you will not be able to apply it in the exam. So what I thought, I'll take a concept, right? Let us assume trends of inorganic chemistry. So all the trends of inorganic chemistry, I'll be taking one topic, the concept will be explained, and I'll be showing you the trend in that particular thing. I'll also be showing you the exception in that thing. So here, most important thing is, sorry for the disturbance. So most important thing is, concept is explained, done. Trend is explained, done. Application is explained, done. Exception is explained. Like that, let us, if I take trends in inorganic chemistry, atomic radii, ionic radii, ionization enthalpy, electron gain enthalpy, metallic property, non-metallic property, ionization potential, or this one, like that, lot of trends are there. So from now, every day, maximum I'll try to upload the videos on everyday basis, but the duration of the video will not be more than 10 minutes. In that 10 minutes, you will understand the concept, you will understand where to apply it, and perfectly you will never forget, I'm saying, because understanding, applying is what is required, isn't it? So every day I'll be uploading, but on one condition, students, if you don't watch the video, the amount of hard work we put, see, basically in 24 hours, the time slot is fixed for us. We're all working women, where we have taken up as a challenge to educate you all. So you as students, you need to utilize that. Ultimately, end of the day, if you don't watch, there is no meaning of any YouTube channel rather. So the subscribers or the viewers are the main root or the backbone of any YouTube channel, correct? So please try to watch it. The day if you don't watch, if I see the video is not reaching many students, it really pains me, because the amount of hard work we put on that, you also should put 10 times more hard work on that. So the both together only will create miracles. So let us start from today, the inorganic series. As I said, this will be useful for 11th, 12th, JEE main, JEE advanced also. I'm going to include some different topics, and NEET students also. So for all the students, I'll be there. Before your NEET exam or the JEE exam, I'll try to maximum complete. Now, in this, what will be there? In this inorganic series, if I have to say, concept maps will be there, one-page revisions will be there, mind maps will be there, trends will be explained. Very simple, I'll try to make it short and sweet videos. But you should promise me that you will watch and be with me. So the upcoming students who are writing the exam, the students who are going to study next year, and this world of chemistry, as I said, it has to reach millions and millions students. When it reaches millions and millions students, you know, if the knowledge has to be shared. It should not be kept, and you know, it's not like this. It has to be shared with everybody, so that you know, that use of making or compiling the video is what is finally achieved. So I have seen students writing, ma'am, we as poor students where we can't afford to go to the school, or we as poor students where we can't pay the fees, your channel is really helping us. Thank you so much for that, students. It is really, I feel I have achieved a huge success in my life. So let us start today with the inorganic series. The first topic, that is atomic radii and ionic radii. In that we will study the definition, we will study the concept, we will study the trends, we will study the exceptions, and finally beyond that nothing will be left to study. Later on, again tomorrow, one more topic, day after tomorrow, like that. So let's start with the first video, inorganic series, first topic. Let's begin.
Hello students, right. So today we'll be starting with the first topic of your inorganic series or inorganic chemistry. That is, we'll be studying in this topic basically about atomic radii, right? So in this atomic radii, basically you'll be asked to start, or you'll be asked questions on two things. That is, your covalent radius is one concept which you should know in atomic radii. So covalent radius is one concept. The next concept would be ionic radius. So you'll be studying the trends in this. You'll be studying about the exceptions in this, as I said, right? So here, basically, when I speak about the covalent radius, let us see the picture and then understand it. Now, let us go to this next page, right? Okay. Now, there is one diagram here. First, let us understand the concept. What actually is a covalent radii? What are you finding here? There is something like, let me pick my pen. Okay. Let us pick one red color in this so that it's clear for you all. Okay, right. Now see here. Are you able to see someone line in this? This is nothing but the covalent sharing, isn't it? Right. So let us write the definition of covalent bond. Basically, when I speak about the covalent bond, how is it represented? Covalent radii or radius rather. Covalent radius is represented by R, small r and CO. This is the first thing you need to understand. Right. If I have to write the definition, what are you finding? Basically, covalent radius is a measure, isn't it? Means we are trying to measure how much is the radius between the shared atom. So it is a measure. That's fine. Then what are we measuring between these two atoms? This is one X and this is one more. Both are atoms, means similar atoms, just like your chlorine is combining with one more chlorine, like that. Both are similar atoms, right? So basically, covalent radius is a measure of which one? Of the size of atom, Okay, this is also fine. I understood this. So I am trying to measure it of the size of atom. Now, when we are going to measure, when it is covalently shared between these two, when it is shared, so we need to mention that it is measure of size of atom, where atom that forms a part of covalent bond, that forms a part of covalent sharing or covalent bond. This is fine, students. So covalent bond is whenever there is covalent sharing, that measure is what is called from here till here, we call it as covalent radius. Done. Now, if this covalent radius, how are we going to measure that? We are going to measure covalent radius either in picometer. So I'll be measuring in picometer, or I can measure this in angstroms. Both the things are fine. Now, when I have to compare 1 angstrom is equal to how many picometers? 100 picometers. Remember this. Okay, this is clear? Yes. So basic idea is I'm going to measure from here till this point. Now, when I have to calculate the covalent radius, what formula I use? So for calculating covalent radius, that is RC. The formula which I use is D A minus A by 2, means the distance between here till here. From here till here, I take it and calculate it. So this is the definition. This is the measured units. These are the this is the formula for calculating the. So here basically you have different formulas for single bond and means the particular atoms. This is fine. Now if I have to speak about the trends of covalent radii, just see, let us see one important thing. I have taken one periodic table and let us mark the trends. These are what is given in the exam, right? So here the first trend, let us see. We very well know when we move from left to right in the periodic table, this is the period. From top to bottom, it is a group, correct? Right. So here in the first trend, let us take the first period. Now see, this is your atomic, atomic radius, which values which are given here. Okay, these are the values. Now here, let us see. When I go from left to right in the period, what is happening? 128, 96, 84, 76, 71. That means in a period when I move from left to right, so let us write the first trend. So in a period when I move from left to right, what will happen? The atomic radius decreases. That means if I have to write the order in a period, lithium is greater than beryllium, it is greater than boron, greater than carbon, greater than nitrogen, greater than oxygen, greater than fluorine, greater than neon. Correct? Correct, students? So here, see here, 128, gradually it is going down. So neon, okay, it is fully filled, little bit more, but as we are going from left to right, the atomic radius decreases. That's fine. Let us come. Why, if I have to say, we very well know the electron adds to the same shell, isn't it? The electron adds to the same shell, and Z effective will be more. Z effective will be more, or the pull will be more between the things. Now, after writing, let us see the order in the 3D series. So, 3D series when I take, now let us see here scandium. Now, what happened in scandium? See here, 170, 160, 153, 139. What is happening from scandium till your cobalt, if I have to take here, till here. If you see what is happening, it is 170 here, it is 126 here. So what happens, you will write the order, sorry, not in the group, you write the order in the 3D series. Let us erase this and take. So I'm going to write now here, let me take the pen. Okay, right. So what did we observe in 3D series? This is one more trend you need to remember. So shall we erase this and write? Okay. We will erase this part and use. Okay. So here the first trend which I have learned is with which one? I have taken. Okay, I have explained here this trend. Now we'll pick up this 3D series. So 3D series I have, as you have observed, scandium is greater than titanium, greater than vanadium, again greater than chromium. You're able to see the values, isn't it? See here, chromium. Chromium is greater than manganese, which is greater than iron, till there. Now, here when I see iron, it is 132 picometer, and here it is 126 picometer, right? So, little bit, if I have to jump to the next one. Cobalt and nickel, see here, almost similar, isn't it? Right? So, chromium is little bit greater than cobalt. Cobalt is approximately equal to nickel. See here. See, this is 126 picometer. This is 124 picometer. This is where your trend is asked. This is where the question is asked. Done. Gradually, when I go copper, again the same thing. Nickel is over. So nickel is again less than. See, 124, 132. Nickel is less than copper. Copper is less than zinc. So your whole trend or the concept is asked at this point. This is where you need to understand. Suppose if they ask you further, you need to relate it to the electronic configuration. That's fine. Now, period, we have seen this, we have seen the 3D series also, exceptions also over. Now, let us take out and learn this one, what do you say, the trends in the groups. So, periods I have seen from left to right, it means as we go, the atomic radius, it decreases. Now, when I have to speak about the groups, just see here, okay. Right, so my groups are, if I see from top to bottom, this is the concept, correct? Now let us see, 31 picometer, 128, 166, 203, 220. What is happening? In the group, concept is number of shells increases, correct? No? Number of shells increases. When the number of shells increases, what will happen to the atomic radius? Atomic radius also, it increases, correct? Yes. Now, if I have to write the trend of this, how will I write? Let us take this eraser and erase it and write the trend. So, period I have written the trend. In group I have to write the trend. Let us see. So, in the group, let us write first thing, lithium is less than, see here, lithium is less than sodium, less than potassium, less than rubidium, less than cesium. Correct? Now let us take one more group. Let us take halogens. See here, 57 picometer, 102 picometer, 120 picometer, 139 picometer. So here if I take halogens, fluorine is less than chlorine, chlorine is less than bromine, bromine is less than iodine. That's fine. So remember, in a period it is decreasing, in a group it is increasing. Shall we write that? In a period it decreases, in a group it increases. Simple concept, isn't it? Right. So now I understood this. Now I need to write the exceptions of this. Shall we write the exceptions? Do we have a page for this? Let us check. Right. In this page, I'm going to put something called exceptions. So this is where you need to concentrate more in the exam. What are the exceptions? Basically, if I have to see, okay, so let us see the table and understand this in the exceptions part. Just let us go to the before page. Now, see here, 4D series and 5D series if I have to see, or the P block elements if I have to see. Now see here, aluminium, where is aluminium? Group 13, aluminium. Now see here, aluminium valence, this one is 121 picometer. What is gallium? When I take gallium, see here, it is 122 picometer. That's fine. It's in a group, as we know, it increases. Okay, right. Now if I have to take the 4D series and the 5D series both, 4D series and 5D series values are approximately equal only. Why? Because there is something called lanthanide contraction. So this is the first exception you need to remember. What is that? We need to note that the 4D series values, that is your atomic radii, are equal to the 5D. What concept is going on? Here due to lanthanide contraction. So if they ask you in the exam, so the reason would be lanthanide contraction. I did a video on lanthanide contraction. You can watch that. Right. And next thing, one more exception I can take is in P block elements. So here in P block elements, aluminium is greater than gallium. Okay, that is fine. Next thing, when I speak lithium, if I have to take, right? So lithium plus cation. Now I'm comparing with cations, lithium plus cation. Then magnesium plus cation. Now see here, lithium, how much is it? 0.76 angstrom. And magnesium 0.72 angstrom. Let us reason this. And next thing, if I take these two anions, what is the value of this? 1.40 angstroms, and here the value is 1.33. Let us first understand why it is. Now see here, in lithium, right, it is 0.76, this is 0.72. Suppose if I take lithium atomic number 3, right, 2 and 1. So you're taking out one electron, this is gone. How much is there? So the lithium nucleus, whatever is there, this is the K shell, this is the L shell. So what happened? Here one electron, here one more electron, two electrons, one electron is gone. Now what will happen to the Z effective? It starts pulling the electron closer towards it, isn't it? The Z effective is more. Compared to lithium and Li plus, where is the Z effective more? In this will be more in this, isn't it? In the cations, the pull will be more. That's why the radius is like this. Suppose if I take magnesium, right? Magnesium 12. So it's going to have the nucleus. This is the K shell. So 2H2, isn't it? So this is the K shell. Done. So next comes your L shell. Okay, this is not proper. Let me erase this and again take it. I'm sorry for this. Let me take that. Right. Now, here in magnesium, again, you have the central nucleus. You have the K shell. You have the L shell. You have the M shell. Right. So, how many total? 12 protons are there here. Now, you're taking out these 2 electrons because Mg plus 2. So, how many? 2 in the K shell and 8 in the 2, 3, 4, 5, 6, 7, 8. 8 in the L shell. Correct? Now what happened? Protons are 12. Electrons are how many? Only 10 electrons. Now obviously it starts pulling those electrons towards it. That's why this is the radius. Done, students? So these are the exceptions of this. Now further there are some more exceptions which you need to remember. let me erase this and take that. I think you have noted. I'll write the next exception here only so that it's clear. Basically, in the exception of P block, okay, I have some space here. Yeah. So here, this is basically the exception in P block, that is indium is almost, the radius is greater than, it's approximately equal to tellurium, and tin approximately equal to lead. So I have given you 3 exceptions based on their electronic configuration and based on their lanthanide contraction. That's fine. Yes. Now, let us now go to the next topic of the concept, that is nothing but your ionic radius. See, as the name suggests, this is your ionic radius. Okay, so ionic radius, let us first explain the concept and then come back. Okay, so what actually is ionic radius? Just see here. Now, these are the atoms. Okay, this is the center nucleus of this atom, center nucleus of this one, this one. So if I have to define the ionic radius, just see here. It is a distance between the nucleus and electron in the outermost shell. Okay. So here, what did we do? Let us assume here we have taken 2 ions. But both the ions are separated, right? So here, if I have to take this way, distance, this is the nucleus, distance between the ion or the nucleus and the outermost electron. This is ionic radius. Now here, what did we do? We have taken the formation of 2 ions. One is the anion and the cation. So this also is called ionic radius, the distance between the centers of the nucleus of both the ions. So from this information, what did I understand? Anion is larger, cation is smaller. So what should I remember for ionic radius? Ionic radius is the distance between the center of the nucleus and the outermost electron. So this is the distance. This is the ionic radius, right? Done. If I have to speak about the ionic radius of the cation anion, you need to understand one concept here. What is that? Just see. Here, sodium, as I said, the radius is measured in picometer angstroms. Now, let us see. Always remember, as I said, cations are smaller, anions are larger. That's fine. The next important thing you need to remember is, compared to the parent atom. Now, parent atom, this is the cation of this. This is the parent atom. This is the anion of this. Now, see the values. Parent atom has 186 picometer. Cation is 95 picometer. Less. Done. Here, parent atom is 99 picometer and anion is 181 picometer. What are you observing? Whenever there is a cation, that means the cation formed, always the ionic radius will be lesser than the parent atom. Remember this. This is one concept. Whenever cation is formed, the ionic radii will be lesser than lesser than parent atom. Why? This is because of electron-electron repulsion. That is what? No, it is very congested inside. One electron will be repelling with the other. Now, here, next important thing when I speak about anion. Okay, here electron-electron repulsion, that means if I have to explain the concept, just like this, this is the nucleus, electrons are placed here, this is the proton, and this is where is the pull in this case, right? Yes. Now, if I have to speak about the anions, now see here, the distance or the number of electrons have increased in this. -1 means number of electrons have increased. When the number of electrons have increased, electron starts repelling, isn't it? It starts repelling. Because of this, the picometer size is increased. Done. Here, the number of electron-electron repulsions are reduced because the electrons are gone down. That's perfect. That's fine. Yes. So what should I remember in the first page? Let us erase everything and see. So ionic radius means the distance between the center of the nucleus and the outermost electron. First point. Second point I need to remember. Always, if I have to speak, cation is, the radius of cation is always less than the parent atom. First concept. If I have to speak of the anion, the radius of the anion is greater than parent atom. So this is the main difference. Done. Let us see the next page. So when I have to speak about the next page, see here, beautiful. You need to remember, nothing to remember about the values, only two concepts you need to remember. So when I have to go, now see here, this is the parent atom which is there. This is the cation which is there. Okay, now let us compare. Just now I said, compared to the parent atom, the cation size is smaller. So Li plus, the cation size is smaller than Li. Let us take one more example. Here, beryllium. Beryllium plus 2 is 0.31. Beryllium is 0.90. Same thing, isn't it? The cation is always smaller than its parent atom. Reason is the same. Right? So here, important thing you need to remember is ionic radii. Okay, so this ionic radii in a period, if I have to speak in a period, okay, right, in a period, what will happen? If they have, or if I have to see how it is distributed, important thing you need to remember, always, one example we will take and see, right? So, most of the things, when you take the anion part, or if you take the charges part, whether it is in the period or the group, what you need to remember, I take an example of manganese. The same concept I'm explaining. I'm taking an example of manganese. Just see here. The order is Mn greater than Mn plus 2 greater than Mn plus 7. Till 7 it can go, no? So the same reason applies here also. Right? Here what happened? Reduced electron-electron repulsions are there. That's why this is the order. Done? Yes. Now, next thing. If I have to speak about the ionic radii trend in a period. So, you can note it. In a period, it decreases. Ionic radii in a period decreases. If I have to take in a group, it increases. Let us see whether it is correct. From top to bottom, when I am coming down, just see here, 0.68, 0.97, 1.33, 1.47. So, in a period, here, 68, 0.23, 1.40, 1.33. So here in a period it decreases, in a group it increases. So that is what you need to remember. Shall we add something else also in here? In this case for anions. Okay. Anions, let us write one order. For the cations we have written this. For the anions, let us take one order. Like for example, Cl minus is greater than U. F minus is greater than. Right, students. So let us start the next topic, that is your isoelectronic species. Now, here basically what actually is isoelectronic species? There was one question which is asked, that is, they'll be giving you in this form, they'll be giving you an ion form and you need to know what is the trend. Right. So what are you seeing here? This is silicon. Okay. This is nitrogen, carbon monoxide, cyanide ion and NO plus ion. Okay. Now in everywhere, what are you observing? You're observing all of 14 electrons. So the first definition is isoelectronic species are those. It can be an atom, it can be a molecule, or it can be an ion. What are you finding? They will have same number of electrons. This is a concept. So whenever you see same number of electrons, you need to know that it is an isoelectronic species. Done. This is okay. Now here, this is what is important. This trend, let us understand how can we solve in the exam. Now, first of all, they will give you in the following isoelectronic species, write the order. First thing you need to remember is, as the atomic number increases, radius decreases. Okay, done. This is due to increment in nucleic Z effective. Okay, this sentence let us understand. First of all, when I have to speak about Z effective, what actually is Z effective? Write the formula. It is nothing but the nuclear charge or the atomic number rather. Z effective or the nuclear charge, the atomic number. Let us write atomic number, it will not confuse you. So the atomic number by number of electrons. This is your Z effective, number of electrons, right? So I'm going to apply this concept in this order and check. Let us erase this and take the space for this. So I know Z effective is atomic number by number of electrons. Let me take that. If I take the first example, N minus 3. What is atomic number? Right? 7 by 10. How did I get 10? Because 3 electrons we've added. Minus means 3, isn't it? So minus 3 means anionic part. You need to add 3 electrons. you get 0.7. This is fine. Next one, I'm going to take oxygen, O minus 2. What is the oxygen atomic number? 8. How many electrons? 2 are added. So 8 by 10, it's nothing but 0.8. Next comes fluorine, F minus. What is atomic number? 9. 9 plus 1, 10. How much it's coming to? 0.9. Now check. See here the values. You're getting the same order, isn't it? So in the exam, if they give you what is the correct trend of this, please try to do this especially for isoelectronic species. So you can take the order, check, and finally write the answer. So this is what is for isoelectronic species. That's fine, students. Now here, after isoelectronic species, next important thing you need to remember is the three different concepts you need to remember. First, you need to remember the trend in the period, trend in the group, trend in isoelectronic species, trend in the atomic radii, that is in the period and group. So this is from my side, signing off. So thank you so much for watching. Always stay happy. This is your Vani ma'am. I'll be meeting you in the next video with the next important concept, ionization potential, right? I'll be giving you the definition. I'll be explaining the trend. I'll be explaining the concept for all of the things for S, P, D, and F, right? So thank you for watching. Bye-bye.